Hello. So in this lecture, I want to talk about standardizing the coefficients. Um, Standardizing means that we want the predictors to be zero mean and unit variance. And if you want to, for reference, you can look at the ISLR book, page 217. And essentially what it says is that least square estimates are scale invariant, meaning that if you multiply the predictors by a constant c, the estimated coefficient will be just divided by 1 over c. So um, essentially, regardless of how the jth predictor is scaled, xj, beta j will remain the same. But for ridge regression or any penalized method, um, the estimates can substantially change when multiplying a given predictor by a constant. Okay, and I suggest you read this. But now I want to, essentially the main point is that it's best to apply regularized regression after standardizing the predictors so that all the predictors have the same scale. Okay, how can we do that? We need to divide them by their standard deviation. Now in R, the GLMNet package, if you look at it, it has many options. One of them is standardized true. So even if you don't set it, the default is true, meaning that prior to fitting, the coefficients, prior to fitting, the predictors are standardized. So inside the function, before it fits the regularized regression, it will standardize the coefficients, fit it, and then return it on the original scale. So we do not need to worry about standardizing or coefficients because that's done inside R. Now, what we need to think about is presentation when we want to present them, because the different predictors are having different scales. Therefore, the relative size may only be a reflection of the different scales they have. So let's just go back to the School of Public Health data, which we have been looking at significantly. Okay. And then here we reordered everything. Okay, we need to start a new session. Hmm. What happened to the data range? So I'm reinstalling the package. Maybe that's the reason. Okay. Hmm. I don't know why this isn't working. Okay, I had to call this library. I didn't have to do it in the past, but anyway. Okay, so here we have these, and what I want to do is I want to plot this in a standardized scale. That's what I want to do. Okay. So we want to look at the standard deviation of the different predictors. Okay, so you see, well, obviously the intercept, the standard deviation is 0, gender is 0.5, church, year's residence. So you see this 10 versus 0.2 have totally different scales. So what we do is we just save these, okay, and what we do is standardized coefficient plots. To do that, you have to first find S, which is the standard deviation, and then we'll repeat the same code we had here. Okay, we have to do this after, because here we change the order of factor levels. We're specifying the order explicitly, but here we're doing it. And here we just copy paste this part. Okay. And now here we multiply them by these standard deviations. So these are estimated coefficients. We don't have S yet. Let's just calculate S. So now we have S. So S to this times S gives us the standardized coefficients. Now the relative importance is expressed in a way that they're all having the same scale, all these coefficients. So I call this normalized. I add norm here, I add norm here, I add norm here, and then okay. Okay, so we calculate the standard deviation. So just let me just remind you, these coefficients more or less mean that 1 unit change of, for example, look at this. So 1 unit change of alcohol consumption on average will lead to a drop of negative 0.04 units of sugar in blood, right? Now, instead of making this 1 unit change, we wanted to make it one standard deviation of alcohol consumption, right? Whatever the variability in alcohol consumption is. That's why we multiply this by S. And the same here by S, and the same here by S. Okay. Oh, okay, I have to add the norms here too. I forgot. Okay, let's do this again. Okay. Okay, so you see a problem. These are not ordered from largest to smallest, and the reason is that um, we need the norm here too. So just to make sure everything is correct, I have to run it from the beginning. Okay, I don't know what's going on with our studio today. Maybe I'm running it too fast. Let's do it again. Okay, so this is these are the unnormalized features. Okay. And now we are ordering them from smallest to largest. Okay. I'm waiting for this plot to show. Okay. So let's go back. Let's look at these. Okay. Now here, all I'm doing is I'm multiplying the coefficients by the standard deviation of the corresponding predictors. And then I'm rearranging them afterwards. So these are now the standardized, the normalized coefficients. So these are the coefficients multiplied by the corresponding um, standard deviation, and suddenly we see coefficients that were not as important. They were important, but at the beginning these were very big, right? Let's just go back. Take some time. I don't know why this is just taking forever. I should run it again from the beginning. Okay, finally. So on the surface, I mean, these coefficients are bigger, right? But they are bigger because this, and these are smaller, right here. But that might be only be due to the fact that the scale here of these variables, which I think the prop variable, these were the prop variables, is different from the scale of the variables here. So now we want to see whether that's the case or not. So just remember, in this range, in the 25 to 50 range, we have these coefficients which are bigger than the later coefficients we have here. Okay. The next part here, we're just changing the order, and that's not really something I want to focus on right now. Okay. Okay. So now we see that these ones, in comparison to these ones, are smaller. So the normalized effect of these coefficients is bigger. That's the whole message I wanted to get across. It took a little bit longer than what I wanted because mostly my R kept crashing and giving me errors, but it's also good, especially for some of you that are new to R, or that sometimes these errors are not because there's something wrong with your code. It's because you're not calling the right package, or you need to restart R. R is open source, so it's normal to have these problems. Okay, so that's it. But this was all regarding the standardizing the coefficients.